Hello friends, welcome to all of you Shiksha 360. Today we have to discuss regarding the chapter number 7 part 1. This topic we have to discuss in two sessions. And definitely you will get 3 to 4 questions from this chapter in your exam. 3 to 4 questions from this chapter in your examination. Near about 25 questions I will provide you in the group for the practice purpose. So let's start our theory portion. So what is the meaning of need for the data warehouse? Clear? So what is the need for the data warehouse? So every day, large and small organizations. So every day, large and small organizations create billions of bytes of data. Clear creates billions of bytes of data about all aspects of their business, million of individual facts about their customers, products, operations, and people. Clear. So every day, large or small organizations that create billions of bytes of data about all the aspects of their business, million of individual facts about their customers, products, operations, and people. Okay. But most of the part, this data is logged in a myriad of a computer system. Clear? But most of the data, it is to be logged up in a myriad of a computer system, and it is exceedingly difficult to get at. So here one word, that is myriad. What is the meaning of that? It is basically large number. So first question. So this phenomena, clear, basically when data it is to be logged up in a large number of computer systems, this phenomena has been described as a data in jail. Clear. So this question I have already asked in the examination. What is the meaning of the data engine? That is when the data is logged up in a myriad of the computer systems. Experts have estimated that only a small fraction of the data that is captured, processed, and stored in the enterprise is actually available to the executives and the decision makers. While technology for the manipulation and presentation of data have literally exploded, it is only recently that those involved in developing the IT strategies for the large enterprises have concluded that large segment of the enterprise are data poor. That is, they are not able to evaluate their data perfectly. So data warehousing, it is a field. What is the definition of the data warehouse? So data warehousing, it is a field that has grown out of the integration of a number of different technologies and experiences over the last 2 decades, basically over the last 20 years. That has grown out of the integration of a number of different technologies and experiences over the last 2 decades to be here. So there are two fundamentally, okay? So there are two fundamentally different types of information systems in all the organizations. So what are these two different information systems? Operational system. Second one, that is the informational systems. Clear? First one, that is the operational system. Second one, that is the informational system. So what is the meaning of that? Clear? So first one we have to discuss it, that is operational system. So these are just what their name implies, that is operation. So these are the systems that help to run the day-to-day operations of the enterprise. So these are the backbone systems of any enterprise, like the order entry, inventory, manufacturing, payroll, and accounting systems. Considering their importance to the organization, operational systems are almost always the first part of the enterprise to be computerized. Okay. So importance of the organization, operational systems are almost always the first part of the enterprise to be computerized. Over the years, these operational systems have been extended and rewritten, enhanced and maintained to the point that they are completely integrated into the organization. Okay. So over the years, these operational systems have been extended and rewritten, enhanced and maintained to the point that they are completely integrated into the organization. Okay, that is, they are completely integrated into the organization, and these are the operational systems are the backbone of the any system, like the order entry, inventory, manufacturing, payroll, and the accounting system. Okay? These are just the examples of that. So on the other hand, there are other functions in the enterprise which deal with the planning. First of all, plan, forecasting, and the management of the enterprise. So these functions are also crucial for the survival of the organization. Clear? So these functions are also crucial for the survival of the organization, especially in the current fast-paced world. So functions like the market planning and financial analysis, clear, functions like the market planning and the financial analysis require information systems to support them, but these functions are different from the operational functions, clear. So functions like the market planning and the financial analysis require the information system to support them, but these functions are different from the operational functions, clear, but these functions are different from the operational functions. So the type of the systems and the information required for these functions are to be different here, okay. So the type of the systems and the information required for these functions, clear, and the information required for these functions are to be different here. So that is regarding the operational system. Now next one, that is the informational system. Informational, that is knowledge based. That is operational, that is for day-to-day work. Information, that is these are the knowledge based system. Clear? So first question regarding the informational system, from the word information, that it is suggests that the knowledge based. Okay, so these are the knowledge-based systems. So informational systems analysis the data and support in making the decisions. So data analysis supports in taking major decisions. Clear? So data analysis supports in taking major decisions like how the enterprise will operate in the future. Informational systems do not only have a different focus from the operational ones, they often have a different scope also. Operational data needs are normally focused upon a single area. Clear? Operational data needs normally focused on a single area, while the informational data needs often span a number of different areas and require large number of related operational data. Clear? And further, it will require large number of related operational data to be here. So with the advent of data lakes, big data, and the advanced analytics, someone within the IT industries have questioned whether the data warehouse it is still relevant or not. The answer is absolutely. Data lakes are the large scale data repositories and store data in the raw form. So what are data lakes? Clear. This is also one of the examples. So data lake, what are the? It is the large scale data repositories and store data. Clear. That is basically it stores the data in the large form and store data in the raw form, where data warehouse store data in a highly structured and transferred form. Clear? So please remember that data lake store the data in the raw form and data warehouse store the data in a highly structured and transferred form. So big data, it is stored in both the structured and unstructured form. Clear? Next point, it is also that is how big data it is stored. Big data is it is stored in both the structured and the unstructured form. Clear? Big data it is to be stored here in the both the structured and the unstructured form. Please tell fast if anyone has any query, any doubt regarding the operational system and the informational system. Very important point. Now move to the next point to be here. So data warehousing can be best represented as an enterprise-wide framework for managing the informational data within the organization. So in order to understand how the components involved in a data warehouse strategy are related, so it is necessary to understand the data warehouse architecture. Now we have to discuss regarding that. And I request all of you, from all these theory-based points, you are able to answer the question only if you are revising all these points at least 2 times. So how the data warehouse architecture plays their role. Clear? What are the important parts under that? So different data warehouse systems have different structures. Some may have ODS, operational data store. ODS stands for the operational data store. While some have multiple data marts. What is the meaning of data marts? We have also discussed. We have to discuss. So in general, a data warehouse it is used on an enterprise level. where while the data mart it is used on a business division or the departmental level. Clear? Please remember that data warehouse it is used the enterprise level. Data warehouse it is used as an enterprise level, whereas data mart it is used as the business division or at the departmental level. Clear? Data mart it is used at the business division or the departmental level. And data warehouse it is used as an enterprise level. So some may have a small number of the data sources while some may have the large number of the data sources. So it is relevant to understand the different layers of the data warehouse architecture now. So what are the essential characteristics of a data warehouse? So fundamental characteristics which define the data in a data warehouse are: first one, that is the subject oriented. Clear? First point which we have to discuss here, that is the subject oriented. So unlike the operational systems, the data in the data warehouse revolves around the enterprise subjects. Clear? Enterprise subjects. So enterprise subjects. So database normalization, it is not subject orientation. So subject orientation can be extremely beneficial in the decision making. Clear? Subject orientation can be extremely beneficial in the decision making. Subject oriented basically refers to the process of gathering only the necessary objects. Clear? So what is the meaning of subject oriented? Basically, subject oriented basically refers to the process of gathering only the necessary object. So please remember that what is the meaning of subject oriented? Basically, it refers to the process of gathering only the necessary subjects. Integrated. Clear? So the data in the data warehouse has been integrated. As data is derived from the several operational systems. Clear? So in the integrated, that is the data in the data warehouse has been integrated. As data is derived from the several operational systems. So all inconsistencies must be eliminated under that. Clear? All inconsistencies must be eliminated under that. Consistencies include naming conventions, variable measurement, encoding structure, physical data attributes, and so on. Clear? So this is also one of the characteristics of the data warehouse. First one, that is the subject oriented. Subject oriented, that is, it is refers to the process of gathering only the necessary objects. Second one, that is, it is to be integrated here. Subject oriented, integrated. Third one, that is the time variant. Clear? Third one, that is the time variant. So unlike the operational system, which reflect the current values as they support day-to-day operations. So data warehouse data represents a long time horizon, basically up to 10 years, implying that it stores mostly historical data. It is primarily intended for the data mining and the forecasting. So data warehouse, basically for what it is to be used, it is for the data mining and the forecasting. Like if a user is looking for a specific customer buying pattern, so the user must examine the data. The user must examine the data on the current and the past purchases. Clear? On the current and the past purchases. Next one, that is the non-volatile. So the data warehouse data, it is read only, which means that it cannot be updated, created or deleted unless there is a regulatory or statutory obligation to do so. Clear? So it is read only, that is we can do not anything regarding the data. Clear? It is to be fixed here. Data granularity. Clear? Data granularity. So it is the level of the details. Clear? Data granularity. Basically, it is the level of the details considered in a model or decision-making process or represented in an analysis report. Clear? So it is a level of details considered in a model or decision-making process. Clear? In a model or decision-making process or represented in an analysis report. So the greater the granularity, the deeper the level of the details. Clear? So it is the level of details considered in a model or decision-making process or represented in an analysis report. So the greater the granularity, the deeper the level of the details. A good example of the data granularity is the name field, which can be subdivided like the first name, middle name, and the last name, or contained in a single field. Here or contained in a single field. As the data fields are more subdivided and specified, then it is considered more granular. Clear? So as the data fields are more subdivided and specific, so then it is to be considered as the more granular. Clear? So then it is to be considered as the more granular. So that is to be considered clear here, that is data granularity. So these are the essential characters: subject oriented, integrated, time variant, non-volatile, data granularity. Now, what are the layers in a data warehouse? Data source layer, Data extraction layer, staging area, ETL. ETL stands for the extract, transform, load. Extract, extract, transform, load layer. Okay. So in general, all the data warehouse systems have the following layers. Data source layer, first one that is data source layer. After that, if we are sourcing, then we have to extract that. Staging area, fourth one that is to the extract, transform, load layer. Clear? So now we have to discuss regarding all these points one by one here. Next one that is the data storage layer, data logic. Fifth one, data storage layer, data logic layer, data presentation layer, metadata layer, system operational layer. Clear? System operational layers. So first one here, that is the picture below the relationship among the different components. This is the metadata layer. Clear? Data source layer, data extraction layer, staging area, ETL layer, data storage layer. This is a source. This is storage. Data logic layer, data presentation layer. Last one, that is the system operational layer. So these are the different layers. So how we can represent that? First of all, we have to source. Then we have to extract that. Staging. Then extract, transform. Staging, that is holding some for understanding purpose. Then we have to transform. Then that we have to store logically, and then in the end we have to represent that. Yeah. In the end we have to represent that. Just a theory purpose, sorry, just for a understanding purpose, we are creating a theory here. Clear? Okay. So now we will discuss regarding all these points one by one here. So for all session, you can join Elective IT batch. So data source layer. So this represents the different data sources that feed data into the data warehouse. Clear? So data source layer, that is, these represent the different data sources that feed data into the data warehouse. So the data received in any format like the plain text, relational database, other types of database, Excel format, etc., can all act as a data source. Clear? So what are the different types of the data sources are? So operations such as sales data, HR data, product data, inventory data, marketing data, and the systems data. Next one, that is web server logs provider using browser data. Clear? Web server logs providing user browsing data, internal market research data, third party data such as the census data, demographic data, or the service data. Clear? All are to be considered under the data sources. So all these data sources together form the data source layer. Clearly, the goal of data warehousing is to free the information that is logged up in the operational databases and to mix it up with the information received from the other, often external sources of the data. Increasingly, large organizations are requiring additional data from the outside databases. So this information includes, this information includes demographic, economic centric, competitive, and purchasing trends. Clear? This information includes demographic, econometric, competitive, and purchasing trends. So how it is to be represented here, now let's discuss regarding that. Okay, regarding the data source layer. This is the first point under the layer. So in this way, general database architecture. So operation system, ERP, CRM, and platforms, all are to be comes under the extract, transform layer. Load. Okay. Then it is to metadata, summary data, raw data. Then OLAP analysis, the reporting, and data mining. What is the full form of OLAP? Very, very important. We have to cover in the part 2 of that. Okay. So first one, that is the data source. Now, if the data it is to be sourced, then next step it is to be in the data extraction. Data extraction layer. So data extraction layer, that is data pulled from the different data sources pushed into the data warehouse system. So there is likely some minimum data cleansing, but any major data transform is unlikely. Clear? So data pulled from the different data sources pushed into the data warehouse. There is some likely minimum data cleansing, but any major data transformation, it is to be unlikely here. Next one, that is the staging area. This is where data sits prior to being scrubbed and transformed into the data warehouse or the data mart. Clear? So staging area, that is, we can say that like the storage or parking area. Clear? We can consider it as to be a parking area. So this is the area, or this is where data sits prior to being scrubbed and transformed into a data warehouse or a data mart. So I please tell fast where data mart it is to be used here. I have already tell for the business purposes. I will show you. Or for the departmental level or for the business division. On the other side, basically data warehouse, it is for the enterprise level. Kindly remember both the points. Okay, so staging area, this is where the data sits prior to being scrubbed and transformed into a data warehouse or a data mart. Having one common area makes it easier. Clear? Having one common area makes it easier for subsequent data processing or integration. Clear? Okay. So having one common area makes it easier for the subsequent data processing or the integration to be here. So third session, that is staging area. Fourth one, that is ETL. ETL stands for the extract, transform, and load the data layer. Clear? Extract, transform, load, okay, layer. So this is where data gains its intelligence as logic is applied to the transform the data from a transactional nature. Clear? This is the where data gains its intelligence as logic is applied to transform the data from a transactional nature to an analytical nature. Clear? From the transactional nature to an analytical nature in the ETL. So this is also where data cleansing is happening. So sometimes data cleansing is happening in which layer? That is in the ETL layer. Extract, transform, and load. So the ETL design phase, it is often the most time-consuming phase in the data warehousing project, and an ETL tool is often used in the layer. So process in the ETL layer, it is showing as ETL process, that is there are different Oracle, SQL, that is Teradata, Flatfill, all are to be extracted into the staging area. Here it is to be transformation and then loading into the data warehouse. Clear? Next one, that is the data storage layer. Clear? After extraction. So this is where the transformed and cleansed data sit. So based on scope and functionality, three types of the data it is to find here. First one, that is the data warehouse, Data Mart, and ODC. Clear? And ODC, that is operational data store. ODS, that is operational data store. So in any given system out of the three entities, you may have just one, two, or all of the three. Clear? Okay. So in any given system out of the three entities, you may have just one, two, or all the three. Next one, that is the data logic layer. Data logic layer. So first one, that is the data source. This is the data storage. Clear? Kindly understand the difference both these points. So data presentation layer. Clear? So data logic layer. So this is where the business rules are to be stored. So business rules stored here do not affect the underlying data transformation rules, but do affect what the report looks like. Clear? So this is where business rules are to be stored. Clear? So this is where business rules are to be stored. So business rules stored here do not affect the underlying data transformation rules. Clear? Business rules, where business rules are to be stored, that is in the data logic layer. So business rules stored here do not affect the underlying data transformation rules, but do affect what the report looks like. Clear? But do affect what the report looks like. Next one, that is the data presentation layer. So this refers to the information that reaches to the user, that is present to the user. So this can be in the form of the tabular graphical report in a browser, or the email report that gets automatically generated and sent every day, or an alert that warns user of exceptions, among others. Usually an OLAP tool or an operating tool it is used in this layer. Clear? OLAP tool or a reporting tool it is to be used in this layer. So what is the meaning of the OLAP tool here? So please remember that what is the full form of ETL? Extract, transform, and load. I will expect that this full form you will get in the examination. Clear? So next one, that is, what is OLAP? Just wait. We will also discuss regarding that. Clear? OLAP in the next session. So next one, that is the metadata layer. Clear? So this is the upper layer. So this is where the information about the data stored in the data warehouse system it is to be stored. Metadata, it is data about data. A logical data model would be an example of something that's in the metadata layer. So metadata tool, it is often used to manage the metadata. So data warehouse contains huge amount of the data. So the metadata component contains the information in different portions, clear, in different parts, contains the information like the first one, that is description of the data warehouse. Rules to map, rules to map, translate and transform the data sources to the warehouse elements. Okay. First one, that is description of the data warehouse. Second one, that is rules to map, translate and transform the data sources to the warehouse elements. Clear? Rules to map, translate and transform the data sources to the warehouse elements. Third one, the navigation paths and the rules for browsing in the data warehouse. Third one, that is the navigation paths and the rules. The navigation paths and the rules for browsing in the data warehouse. Fourth one, that is the data dictionary. Clear? Fourth point here, that is the data dictionary. Fifth one, that is the list of pre-designed and built-in queries available to the users. Clear? So all these are the components of the metadata, that is description of the data warehouse, rules to map, translate, and transform the data sources to the warehouse elements, the navigation paths and the rules for browsing in the data warehouse, the data dictionary. Fifth one, that is the list of pre-designed and built-in queries available to the users. Record description in a COBOL program, dimension statements in a Fortran program. Clear? Record description, that is, it is in a COBOL program, and dimension statements, it is in a Fortran program. Or a SQL create statement fields are examples of that metadata. Here are SQL create statement fields are the examples of a metadata. So in order to have a fully functional warehouse, it is necessary to have a variety of metadata available. That is data about the end user views of the data and data about the operational database. So ideally, end users should be able to access the data from the data warehouse. Clear? Ideally, end users should be able to access the data from the data warehouse or from the operational database without having to know where the data resides or the form in which it is to be stored. Clear? Where the data resides or the form in which it is to be stored here. So next one, that is the system operations layer. So this layer includes information on how the data warehouse system operates, such as ETL job status, system performance, and the user access history. Clear? And the user access history. So which layer? That is the system operational layer. That is, this layer includes information on how the database system, warehouse system operates, such as the ETL job status, system performance, and the user access history. So data warehouse options. So there are perhaps as many ways to develop the data warehouse as there are organizations. Moreover, there are a number of different dimensions that needs to be considered. So scope of the data warehouse. What are the dimensions? That is, first one, scope of the data warehouse, data redundancy, that is data repeated, type of the end user. Clear? Third one, that is the type of the end user. So figure 7.4 shows a two-dimensional grid for analyzing the basic options, with the horizontal dimension indicating the scope of the data warehouse and the vertical dimension showing the amount of the redundant data that must be stored and maintained. I think I forgot to include that image. Clear? I will include in the next session. Clear? So what regarding all these things, that is scope of the data warehouse, data redundancy, and the type of the end user. Clear? So what the figure redundant data that must be stored and maintained. So now let's discuss data warehouse scope. So the scope of the data warehouse may be as broad as all the information data for the entire enterprise from the beginning of time, or it may be as narrow as a personal data warehouse for a single manager for a single year. So there is nothing that makes one of these more of a data warehouse than another. Clear? So it depends upon case to case. Clear? Whether the informational data that is for the entire enterprise from the beginning of the time, or it may be a narrow as a personal data warehouse for a single manager for a single year. So in practice, the broader the scope, the more value the data warehouse is to the enterprise and more expensive and time consuming it is to create and maintain. Clear? So in practice, the broader the scope, the more value the data warehouse it is to enterprise, and the more expensive and time consuming it is to create and maintain. As a consequence, most organizations seem to start out with the functional, departmental, or the divisional data warehouse. Clear? So as a consequence is, or as a result, most organizations seem to start out with the functional, departmental, or divisional data warehouses. Clear? To start out with the functional, departmental, or divisional data warehouses, and then expand and them as users to provide the feedback. As users provide feedback. So in general, a data warehouse it is used as an enterprise level, where the data mart it is used on the business division or the departmental level. A data mart only contains the required subject specific data for the local analysis. Clear? So a data mart only contains the required subject specific data for the local analysis. Clear? Specific data for the local analysis to be here. Next one, that is the data redundancy. Clear? So data redundancy it is a condition created within a database or data storage technology in which the same piece of data it is to be held in two or more places. Clear? Redundancy, that is same data it is to be existed at the different places. Clear? That is to be redundant here. This is the meaning of the redundancy. Okay, so data redundancy, it is a condition created within a database or data storage technology in which the same piece of the data, it is held in two or more places. Essentially, three level of data redundancy an enterprise should think of when considering their data warehouse options. Clear? So what are the three levels of the data redundancy an enterprise should think? That is first one, that is virtual or point-to-point data warehouse. Clear? Data redundancy that is under that. First one, that is virtual or point-to-point data warehouses. Second one, that is the central data warehouses. Third one, that is the distributed data warehouses. Clear? Third one, that is the distributed data warehouses. So there is no best approach. Each option fits a specific set of the requirement, and a data warehouse strategy may ultimately include all the three options. Clear? So it depends upon case to case. Either it is to be the virtual or point-to-point data warehouse, or it is to be central data warehouse, or third one, that is the distributed data warehouse. Clear? Virtual, distributed, or central. Clear? It depends upon case to case, or sometimes all are to be included here. Clear? Sometimes all are to be included here. Okay. So in this session, we have to discuss up to this much point. Okay. So in the next session, we will cover the rest portion. Clear? Along with the some other important points. Clear? So in this session, we have to discuss up to this much point. In the next session, we will start from the virtual or point-to-point data warehouse. Okay. So I request to all of you to kindly revise all these points, and definitely you will get straightforward questions from these points, whatever we have discussed till now. So thanks to all of you for joining this discussion.